I will talk about natural language processing in Go. But let me first introduce myself a little bit. My name is Matteo Grella. I'm the head of artificial intelligence at the EXOP Group. We are trying to apply, or actually we apply AI to detect the security incident. I think what is most important today is that I'm a Go lover as much as you are. And what can I say? Her name is Happy. Let me also make the laser pointer, should be better. She's happy. And I research on my free time, on my working time, almost every time on natural language processing and related machine learning algorithms. And I'm the creator and maintainer of spaGO. So I really try to combine my love of Go, my love of NLP, and try to build something unique. So spaGO is the library I'm going to talk to because it can support natural language processing in pure Go. And after a short introduction about the basic concept, we will have a short tour with the current NLP capabilities with ready-to-go examples. So please take a note of those two links. Anywhere not so hard to remember, it's just github.com and my name, and you will find immediately the GopherCon EU 2021 repo, and all the examples I'm going to explain here in this presentation will be there, ready to work. And I will conclude with a short roadmap about this library. So let's begin. What is spaGO? spaGO is a self-contained machine learning and natural language processing library in pure Go. What do I mean in pure Go? Well, first, I'm not using spaGO at all. So I cannot even compile a static binary. So we are not using any external third-party deep learning frameworks. There are some cool libraries in Go that are bindings of TensorFlow or PyTorch, but there are some limitations. For instance, you cannot really train your neural model, whatever there will be. I will explain, in a second. In spaGO, it's all in Go, and you can perform inference and train your deep learning models. And this makes particularly suitable for embedded systems. Just think the Docker image, which basically the deployment of deep learning models are quite hard if you go from Python. Here is just 20 megabytes. So it's really great for production. And you can use in both command line interface mode or as a library mode. It's of course a Go module. So a little bit of math, because it's crucial in a machine learning framework or in a machine learning library that needs to have an internal lightweight machine learning framework. So basically, the framework is nothing else than a way to create an expression graph, or or a computational graph. So let's bring this expression. We have a sigmoid where we combine the multiplication of weights, the W, with X, let's say our input, plus B, our bias. And it's all about creating this structure. So this graph that represents exactly this expression. So we have the first variable, W, this scalar variable, X, and then they will be multiplied, added together with the variable B, and then all of this pass through the sigmoid, which is just a simple function, exactly this one, by the way. So how can we obtain this with the spaGO? Well, with this 20 line of codes. So we define a new graph, which is, as you expect, just a graph. You insert some variables or nodes inside the graph. For debugging purposes, for these examples, I even make the names. So this is the W, the B, the X, with just a simple scalars, for example. And then here we make the equation. So we start multiplying with G dot mul, which is multiplication, W with X, and then we sum the result with B. And after that, we obtain the sigmoid. And please consider that this graph on the right side is obtained exactly with this code. So we use the GraphViz tool that allows to render dot files. So dot is just a format that allows to render SVG or images, PNG, etc. So why do we need to transform an expression in a graph? Well, because machine learning, especially deep learning, is all about backpropagating gradients. So what is a gradient? I don't want to express mathematically right now, I have no time for that. But in general, imagine whatever will be your neural model, create an output. So this is the same formula as before. And our output has been to match against the expected output. So our target. So for instance, I would try to show the computer a banana, and it would say, it's an apple. No, it's not an apple, it's a banana. So this is the difference between my expectation and the actual output, create this sort of gradients from the loss function or objective function, this one. And the gradients went through back all the graph until the parameter, which are nothing else than variables, with the difference that they are fixed then, they are stored to form the neural model knowledge. So the knowledge of a neural model, so the result of a learning process, are the way the parameters, meaning the vectors or matrices, the values of those matrices or vectors. So more practical inside spaGO, in order to define a neural model, we need to define basically a structure, the model, and a forward operation, where the forward is the sequence of expressions that compose a neural model. That's recursive, I know. So the model is a parameter. I use the text from Go, so the weights, biases. We have some differences when we use neural models between those two type of parameters, the weights or biases. It doesn't really matter right now. They're just variables. And in the forward operation, we use those variables in order to create the computation. So from our input to our output. And if we have a look just at this little model, was not so little because the LSTM, the neural model I just show you, is basically what you have in WhatsApp or your in messaging applications that try to predict the next word. So, you know, when you're trying to write your wife, I'm at whatever, then the next word has been suggested by a model, which is most likely the LSTM, at least 5 years back. Now the models are a little bit more sophisticated. So, you know, this is quite complex, and it's just a minimum model suitable for natural language processing. It's a recurrent model. So use cases. I talk about math, but my presentation is about natural language processing. So we use the math to build NLP application. And you want to use Pago for social media monitoring. For instance, you have a bunch of tweets and you want to analyze, okay, this is positive, this is negative, so sentiment analysis. Or you want to build a chatbot. So you need a system that is able to read the text and maybe try to give you answers from your questions on that text. Really closer to customer support services, just improvement for your search tools to perform content classification. You have two texts, what is sport, what is cinema, what is, I don't know, security, economy, finance, or just spam, not spam. So NLP is all about that. It's about making meaning on text of unstructured data. And of course, really immediate to understand language translation. So I have a text in Italian, and I want to transform that text in English, in Spanish, in Russian, in all the other languages, or the way around, etc., etc. And of course, spaGO is particularly okay for educational purposes, because the way I build spaGO is straightforward, so you can really understand without any knowledge, almost any knowledge about math or physics or something like that. But of course, from the mathematical model to a use case like a chatbot or sentiment analysis, there's a huge gap. And if we were in Python, well, no problem, guys. There is Hugging Face, a splendid company, which is now the point of reference of NLP in the Python ecosystem, especially, where companies like Google, Facebook, Amazon, Microsoft, or university, and even individuals are all there to share their trained models. And please consider that train a state-of-the-art model takes time, can take months, and depending on the power of your CPU, or even better, your GPU or TPU, but still, that's an effort. So with Hugging Face, the Python ecosystem can use out of the box with the transformers library. This is the main library from Hugging Face. Models to perform summarization, question answering, text generation. So I give a text and I can ask, please machine, continue generating this text for me. Machine translation, zero-shot classification, which is classifying without any training set, etc., etc. But luckily, with spaGO, we also built a neural model importer. So we can rely on all the power of the Python and PyTorch, especially ecosystem, kindly released by Hugging Face hub, to import inside spaGO those models. So we had to build auxiliary library, which is called GopherCon, because usually the pre-trained models for Python has been serialized in Pickle, which is a serialization format built in Python. So and we don't want to touch Python. We wanted to stay in pure Go. So we had to write this sort of virtual machine capable, able to deserialize the neural structure and import back into spaGO. So this importer takes care of downloading a neural model and convert them in this spaGO format. So let's be now really concrete, because after my presentation, I would love you guys to have a look at spaGO and try to use in your use case, in your Go programs as a library. Because I forgot to mention, with spaGO, in the repo, you will also find the Docker file. So starting a Docker using spaGO is actually straightforward with Docker. But then the question is, what is the benefit of using spaGO or using other Python library embedded inside a Docker? So now let's take in using spaGO as a library. So basically the model start for also the other examples in the same way. This is for name entity recognition. We load a model. And now it's really straightforward example, no checks, so you should care about this. The first argument is the path of the neural model. Then we have to remember with the nice defer to close the model. And by the way, the name entity recognition could be cast as a sequence labeler task, like the sequence of word, and for each word you have to make a tag of that word. So, and in this example, I just make for each standard input. So for each input in your console, I call this function, and the function do nothing else that asks the model to analyze this text. It doesn't really matter right now what are the other arguments. There are some options I don't want to talk right now. And then you can loop the results and print them in console. And this is the example. So Matteo Grella was born in Turin, Italy on December 18, 1987. And in output, you will find Matteo Grella, so this token extracted from my original text, tagged as a person. And Turin and Italy has been tagged as a geopolitical entity, GP. And December 18, 1987 as a date. And this is already quite complex, this model, because in a sentence like he's the head of AI at EXOP GmbH, both EXOP and AI are capitalized in my text, but yet the system is powerful enough to recognize EXOP GmbH as organization. So before moving to other examples, this is quite nice, I think, as a capability built inside spaGO to allow you to create a gRPC client server. Because, you know, loading a neural model takes some RAM, and depending on the model, or even 1 gigabyte to 2 gigabytes. So sometimes it's better to load a server with the neural model, and then use a client with gRPC in order to ask the model to perform the prediction, in this case, name entity recognition. And yeah, I think it's this is on the repo examples, so you can test also that one. To proceed with other examples, and also to clarify, how can a model perform name entity recognition with such high accuracy? I didn't mention the accuracy, but we're talking about state-of-the-art models. It's up to 93 to 94% of accuracy in a standard data set. Well, because sometimes, and this is one of the cases, neural models rely on a language model. So neural model, language model, I know that could be some confusion, but a language model is a model where, given a word, try to predict the next word. So you can make the first word by yourself as a user, and then ask the machine to predict the other word. And then the machine can use the other word automatically predicted to generate the subsequent word, etc., etc. Well, now we are in an extreme case where we're not talking about words, but we're talking about characters. So every single characters. And here in my example, I just make a sort of seed. So I try to help the model a bit, writing Italy. And then the model proceeds automatically, character by character, a country that has been seen as a partner and the only country to have a population. Wow. Well, I mean, of course not. Can be Italy the only country to have population? So we see it's still a machine. So it's stupid. We are really far away from Terminator and Skynet, etc. But yet, the machine is without any doubt that acquires some knowledge about humans' knowledge. For instance, Italy is a country, we have a concept of population, or I really enjoy this, the system continue with beautiful thing, or I'm very sad for, the system continue with some expression which said for the course of the season, also for me it's quite okay, and also we're dead. So if you look at the sentences, they are basically meaningless. But in terms of grammatical and syntactical structure, or even about words, is already quite a miracle that the system, character by character, predict even a white space, just the space between words, all by the system. But of course, that model is not powerful enough to make really, not general intelligence, but like a question answering or automatic summarization or automatic translation. So that's why, to my mind, 5 to 6 years back, Google came up with a masked language model. And here the task is not anymore to predict word by word, but is given a complete sentence and one or a few more masked word. So word that I replaced by purpose with an unknown word, which is this mask symbol. The system has been trained to predict the missing word. And of course, it's clear that the system must acquire enough knowledge in order to recover with the context of the sentence the missing words. So this is the truth. I'm so masked to talk about this topic, the model automatically generates excited. Or the mask of this neural mask is impressive. And where the system is cool, the efficiency of this neural network is impressive, etc. Until something really border. Berlin is the capital of, the system bring back Germany as the most candidate word to replace this mask. But then if we invert and we say mask is the capital of Germany, then the system says Frankfurt. I cannot say it's completely wrong in terms it could be like financial capital. I mean, I have no really strong experience in Germany. It's not completely wrong, probably, but yet surprise us. So this model needs to be refined, which is the process called fine-tune, to allow subsequent tasks, high-level tasks. So at the basis, we have the language model, now the masked language model, and now we are going through the question answering example. And let me repeat myself, all of these examples are inside the repo, so it's GitHub, Matteo Grella, and you will find the GopherCon repo, and you will have all of this ready to go. So with this example, as usual, we load a model. It's not anymore a sequence labeler. Now it's BERT, which is bidirectional something from Google. I don't remember exactly the acronym. Encoder for transformers. I don't remember really. And we read from a file a paragraph, and which is what I put on the top here. So it's just a paragraph from Google. For the description of Go, when it's been created and something like that. Then we ask the model to answer respect to this paragraph to my ongoing questions. And then we can even play with confidence level. So with spaGO and with these neural models, most likely every answer, every prediction you get from the library are associated with a confidence level. So you can really play in your use cases, your application, say, okay, maybe less than 0.5 in a scale 0 to 1 is really uncertain. So let's make a fallback answer like, sorry, I'm not so sure. Otherwise, let's print the results. Let's use the predictions. And for instance, here, my question is, what is Go? And the system extracts a span of the text, which is a programming language. It's really sure, it's 93% sure. When Go was created in 2007, it's 96% sure, even more sure than the former question. What is the purpose of Go? Sorry, I'm not so sure. But then if we reformulate just likely the question and we say why Go was created, it extracts from the paragraph to address criticism of other languages. And also there, the system, for me, is absolutely right, the answer, but it was not so sure. Then who invented Go? So we see that the system is capable to even include the conjunctions and coordinates and comma and the end, etc. And when was Robert working when he created Go? So it's a complex question. Google, 100% of accuracy. And all of this in 30 lines of code. Zero-shot text classification. Well, text classification, as I mentioned in the very beginning of the presentation, is the task to say, given a text, what is the most likely class? So is a sport, is basically what you want. But for this what you want, you need the training sets, huge training sets, especially if you are using a state-of-the-art models. So a pre-trained language models, trained for a month with GPUs, with the huge amount of text. You need really quite a amount of examples for your use case. So there's a way to avoid to use at all this training set with the zero-shot text classification, where in this case, it works for English, but there are also multilingual models or models for other languages. You can define an arbitrary list of topics. And in my case, I say positive or negative, but could be high priority or low priority, could be basically whatever you want. And then you ask the model to classify your text, your ongoing text, with those against those classes. And then I just print out the distribution, and the distribution is sorted by the confidence level. In this case, we have positive or negative. So I got a promotion at work. It's positive, no doubt, 98%. And negative, just 0.02 is nothing. I've been working at a company, but I got fired. Well, it's negative, no doubt, 90%. But yet you were working, at least that's my human interpretation of why the machine creates also 10% of positive. And please notice that the machine neural model, the explainable neural model, are really a huge topic of research. So it's really hard to understand exactly why a neural model gives you a sort of prediction, and you have to take care about this during your use cases. Then I'm pleased with my new phone, but it has a short battery life. Well, this is really ambiguous, and because you are happy, but the battery life is short. So also the system reflects that, positive 60%, negative 40%, and you can deal with that. Cross-lingual text similarity. You can make FAQ, you can make a lot of tasks with this. And it also expresses really clearly how a neural model can reason with your text, with text. Basically, the text the model has to transform your text inside a mathematical representation. In our case, a slice of float 32. And then we just split our input by pipe, and we ask with the dot product that together with the normalization reflect the cosine similarity. Cosine similarity is a way to measure angles of two vectors, and it's a sort of similarity measures. And then we say, I love my dog and I enjoy my puppy. It's 81% similar. I love my dog, I love playing guitar. Is 54% similar. It's still similar, I'm loving something, so okay. But it's already quite different. And then last one, I say, amo il mio cane, which is Italian, so I can guarantee is exactly the same as I love my dog, is really high. And we can never expect 100%, just because we have different languages, so it can never be 100%. And this is in German, this is in Russian, but this model, for instance, performs well with more than 19 languages, to my mind. This is another example, same text similarity. So the process is exactly the same, the vectorization. The only difference is that I load from a file a bunch of sentences. And there's some noise out of the window, sorry. And then with this, the system tried to rank by similarity to your input the sentences inside that file. Let's conclude with the machine translation, which I found quite impressive, as in 22 line of codes, we can perform a translation from a language to another. So this is a machine translation written in pure Go. Can you believe it? It's really the translation of this Italian sentence. So as before, we ask the sequence-to-sequence, this time, model to load the model from file. Then with the fare, we gently close. And given our text, which is the original text, we ask the model to generate. By the way, the sequence-to-sequence model is the same, this very same model performing automatic summarization. So now we are trying to, you are really going to appreciate the neural models. And for this, for translations, you will find this GitHub link, a production-ready HTTP, JSON, and gRPC API translation service, which is a little more powerful than this little example. So, conclusions and future works. Well, we have to admit, I hope you will agree with me, that Go is very suitable for numerical computation, and especially for AI development. So please join the project and help us to improve even further the capabilities of spaGO, writing issues, asking questions, and what we have in mind. In terms of roadmap, we want to include new models and new state-of-the-art models. We will try to optimize as mainstream frameworks like PyTorch or TensorFlow. We are working on quantization, so to optimize dramatically the speed of the model. We are trying to move certain models from a float 32 to integer computations. And of course, merge with the other amazing project in Go, which is called Gorgonia. We are trying to merge our two projects to make spaGO GPU and TPU friendly. So many thanks for your attention, really appreciate it. My name is Matteo Grella. You can reach me via email or via Twitter. And please remember this GitHub account. Many thanks.